doing a lot of work over the last year, all aimed at making it easier for you to weave together many large graphs and end up with just the data you need in exactly the shape you need it. That's the promise of GraphQL, after all. First, let's take a look at the state of GraphQL and federation today. So I'm in this club where we read inspirational fiction. We've got an app that lets us keep track of what we're reading and take notes on it. That app talks to a GraphQL backend, because of course it does. This is the graph. So we can query readings, we can query users, and users can leave notes on readings. It's a little benzene ring of data. Now, when I said here's the graph just then, you may have been expecting something more like this. These are two views of more or less the same thing, although our little floating space graph has a little bit of information pruned out for simplicity. I started with the graph, that is the physical graph, because it looks really cool, to be honest, but also because I want to move away from syntax just a little bit and invite you to start thinking about these graphs as structures, and specifically as structures we can manipulate, shift and fold and reshape. In this space, types are places you can be, and fields are journeys. They are ways that you can move from place to place. Resolvers teach us how to take a journey. So when we receive a query, the resolvers know how to take us to the data. Now, if we didn't have GraphQL, we would still be able to expose this data. We would just come up with some other interface to request it. GraphQL gives us a common language for expressing the shape of our data. And yes, that makes accessing it easier. But it's more than that. A friend of mine once said, every problem in computer science can be solved with another layer of indirection. And GraphQL is another layer of indirection. I probably shouldn't say this at a GraphQL summit while working for the GraphQL people on GraphQL, but GraphQL is ultimately kind of a stupid technology. And I mean that in the most loving, programmery way possible. It is beautifully stupid, beautifully simple. It's basically describing all of your data as a big typed JSON blob. Anyone could have designed it, and in fact, everyone did, and everyone did it differently. But a common language is a powerful thing. With a common language, we can connect disparate clusters of concepts and data. The common language creates a new space, a data layer that holds the graph of everything. So some folks from the book club started a film club, which also has a graph. This one is more of a tetrahedron. It's interesting to me how the layout engine here, which is 3D Force Graph, it's using D3's Force engine and 3JS to go and render all of these blobs. The layout engine forms these stereotypical shapes based on the structure of the schema. So in GraphQL, a lot of our relationships tend to be bidirectional. Ratings have a film has ratings. And you can see how many such relationships there are by counting the cycles. This is the schema for that structure. It's a little bit more complex. Now this graph is not connected to our other graph, but we can still think of them as existing in the same space. They just don't have any crosslinks. They're disconnected. But they both key their users on email, because I wrote this example and I cheated, so we can kind of do a query across them. But since they're disconnected, we have to join the data manually. To get all the readings I've taken notes on, I'll query agitprop. And then to get my film ratings, I query obscura. Then we glue them together in the front end. Now that works, but it's not exactly ideal. We're breaking the GraphQL promise of making one query to feed the front end. I have a solution for this, and naturally the solution is federation. Now to link these two graphs with federation, we don't actually have to change our schemas. The schemas don't know about each other, and they don't have overlapping names, so we should be able to just connect them into a new graph, the federated graph. The federated graph joins our other two graphs. You can think of it as a projection of both of them. And it's quite a faithful one. It contains all of the types and fields from all of our services, with the same names and arguments and so on. You can even see that the layout engine has given it more or less the same shape. It also has links to the source graphs. It knows where all of these types and fields are from, and how to get from one graph to another. So now we can express our request as a single query against the federated graph. And when we run the query, the gateway knows what queries to issue against its subgraphs in order to resolve the data that we've asked for. So that's federation as it stands today. And it's already incredibly powerful. A lot of organizations are already getting tremendous benefit from it. It effectively gives us the reduce part of MapReduce. We can combine two or more things into one. Only the thing it's operating on is not our data, but the structure of our data. As with MapReduce, this lets you parallelize work. Only in this case, the work is the human work of cataloging and structuring our data. It's the work of growing the graph. With federation, you can have multiple teams, each working on growing the graph, and so it grows in parallel, which means it can grow very fast, which means it can explode. Now that's very exciting, but it can also be a lot. The amount of accessible data in your organization, and frankly, the amount of accessible data in the entire world, is enough to make anyone's brain start dropping frames like my computer is right now. Massive graphs create new, massive problems. You still have one graph to reason about, but now it's made of tens or hundreds of subgraphs, each likely maintained by a different team. You have to make sure they fit together, make sure nobody is stepping on anyone else's toes. There are also some use cases that federation doesn't handle yet. When we federate graphs today, we end up with a combined graph that looks a lot like our subgraphs, same names and types and fields. But what if we want to change that? What if we want some more flexibility in terms of how we merge our graphs together? Some of you might remember schema stitching. Some of you might still be using schema stitching. Schema stitching was kind of a precursor to federation, a more bare metal way of merging these graphs together. With schema stitching, you could basically do whatever you wanted to the subgraphs, pruning and reshaping fields, changing types. But schema stitching was very ad hoc. Literally, you'd be writing some JavaScript that manipulates the schema ASTs more or less directly. Now that's extremely flexible, but it's also quite hard to reason about. With federation, we can and do run validations on the composed graph. Schema stitching doesn't really allow for that because outside of the requirement that it be a valid GraphQL schema, we really have no way of knowing what you wanted, so we have no way of knowing if the stitch schema is correct. But what if we could have both? What if we could have the verifiability of federation with the flexibility of schema stitching? Earlier this year, we sat down and asked ourselves this question. What's next? How do we build on federation? How do we develop tools to wrangle these increasingly massive graphs? We've called the result Project Constellation. Project Constellation is an evolution of federation, developed with a few goals in mind. One, we knew we wanted it to be faster. To that end, we're rewriting the query planner in Rust. Now, this doesn't mean that you have to write anything in Rust. It also doesn't mean that we've given up on JavaScript. Our intention here is to provide a drop-in replacement for the current query planner within Apollo server. When it's ready, all you'll have to do is update your gateway to get the benefits. Now, we're also not just dropping in Rust and expecting things to get faster. We're also doing a lot of testing. We're building out benchmarks and using them to explore design patterns that can exploit the many, many cores that today's servers have available. Longer term, we're developing workflows to reduce the work that the gateway does, such as schema composition, by moving it to an ahead-of-time compilation step. That ties into our next goal, which is to make federation stronger. We'd like to be able to provide better validation information earlier in the development process. When you're working on some part of your graph, you should be able to compile the whole thing during development locally and see if there are any problems. And the tools to make that possible will give you a lot more insight than you have today into how the graph of everything will link together. And that's important because we're also making federation more flexible. For starters, we want to bring back a lot of the customizability of schema stitching. Also, everything in Constellation is being built to stream. We are taking this opportunity while we're rewriting the query planner and ultimately the gateway to build all of these systems with subscriptions, live, and deferred queries in mind. Finally, flexibility also means compatibility. This was a very important design criteria. We absolutely did not want to introduce any mandatory changes on the client side. All the new shiny features we're about to talk about will work with existing GraphQL clients. They'll also work with existing federated services. And in fact, they'll work with services that are not currently federated. Federation requires a little bit of work to implement. You have to declare keys and entity resolvers and so on. And you may still want to do this. There will still be some reasons to do this, even in the future. But you'll no longer have to. Constellation gives us tools to federate services that have not implemented federation. It lets us weave together graphs that don't know that they're being woven. Let's see how. Let's go back and look at that federated query. Now this query gets us all of the data we want, but the shape is weird. We're getting back user.notes and member.ratings. And I'm sure we can reshape it in the front end, but the whole point of all of this is that we shouldn't have to do that. Our graph should be shaped how we want it to be shaped. The problem is we didn't modify our underlying services. So we still have these separate user and member types, which means we still have to query them in independent query branches. To federate the service properly, we would probably merge the types into a single user type, defining email as a key. This would let us query everything together. But it's still not ideal. Thing one, we've arbitrarily decided that agitprop should own the user type, and obscura should extend it. We could have gone the other way. It doesn't really matter. Ideally, though, we'd like to avoid having to make decisions where the result doesn't really matter, especially around a concept with emotional charge, like ownership. This change also means that obscura's query.member field now returns type user, which is odd. We could change it, but we probably won't because the field deprecation dance is kind of a pain. The problem really is that we had to change our services. We also had to write some code. We had to write these entities resolvers. And those resolvers do things that we already have resolvers to do. And so it's a bit frustrating that we had to define them at all. Now this example is synthetic, but these aren't uncommon problems. This is basically what you run into whenever you're trying to link two graphs that have grown independently. They're going to have some overlap, and so the unified schema is going to have some oddities to it. Under federation today, fixing those oddities requires changing the services. Constellation is going to give us some tools to improve the situation without doing that. Before we dive in, I want to bracket this. Nothing we're about to see is set in stone. So everything here is a draft. This is the direction that we're thinking about going, and its shape is almost certainly going to change by the time we get there. It's already changed quite a bit. So if you have thoughts, good or bad, please share them with us along the way. The first thing I want to show you is a new argument to key, via. This argument tells the gateway what query to run to resolve an entity from this key. The query planner is smart about the types here. So if you have a field that takes an array of keys and returns an array of entities, it'll get called in a batch fashion. And if it doesn't, the query planner will generate multiple query branches. Now we don't have to write the entities resolver. We still can. Resolving via entities is still the default, but we don't have to. which means we don't need to make any code changes to our services. Except we did rename a type. We changed the name of member to user. Try. So to address that, we're going to have to do something new. We're going to write a schema for the federated service itself. And that makes some sense, right? A federated graph is, after all, a whole new graph. I mean, it has connections to the other graphs, but that's basically an implementation detail. In Federation today, that schema is generated purely by composing our subgraph schemas. And Constellation gives us more control. So here's the unified schema. This is just GraphQL. We've introduced a new directive here, include, which includes other graphs into this one. The graph argument lets us specify what other graphs to include. In its simplest form, it just takes the name of a subgraph. And that's what we're doing here with agitprop. But we can also use a query-like syntax to select, and in this case, alias types from the source schema, giving us control over what types are included and how. Then we extend the joined user type with keys for each subgraph. This part isn't really new, although we're using the new via argument. With this joined schema, we don't have to change the underlying services at all. Instead, we're telling the compiler exactly how we want our graphs to be composed, and it's following along and teaching the gateway. Now, we can still do a bit more. Right now, our graph is pretty spare. In particular, the notes that we can take on readings have a position, but no text, and so the front end has to go and query the text from Project Gutenberg independently. We can fix this. If Project Gutenberg has a GraphQL API, we can add it to our services list and federate against it. As far as the gateway is concerned, it's just another service. And then we can do this. So what we've done here is introduce a new directive, the from directive, which says, in order to resolve this field, go and run this other query. Now we have the text of our readings. We also have the answer to one of the most common questions I get asked, which is, how do you call into a resolver from another resolver? Currently, we don't have a great answer for it. You just kind of do it. You get a handle to the schema, and you call execute on it with your query. And that means that that subquery is left out of query planning, which is unfortunate. And it also means that if you are in a federated graph, you are going to have a problem because you can't get a handle to the federated schema. You have to call into the gateway as though you're a client coming in from the outside. Not ideal. From solves it. The query we specify here has a couple of new pieces of syntax. This new query syntax isn't exposed to clients, but it's pretty important to have here in the data layer. The new pieces are graph identifiers and dotted paths. So the graph identifier tells us how to query tells us to query the Gutenberg subgraph, which we've configured in our services list. We need the dotted paths then to go and dig into the search results and lift the text of the first one up so that it can be its own string field. In keeping with the spirit of GraphQL, dot paths are acting like optional chains. So if any step is nullable, the whole thing is nullable. And if any step fails to resolve, the whole thing returns null. This turns out to be pretty powerful, especially when you start thinking about larger graphs, and, as in this case, external graphs. So there's power here. But the developer experience is maybe a little bit lacking. I mean, are we really going to write schemas where most of it is in string arguments to directives? What if we could write something more like this instead? We call this a star schema. This is a proper superset of GraphQL. So instead of include directives, we've introduced a type spread operator. This works a lot like the existing fragment spread operator, but instead of adding selections to a query, we're adding types into our schema. You'll also be able to use the syntax to spread the fields of one type into another. The other new piece of syntax on display here is the assignment operator. We're assigning the text field to a query. That query is using the same extended query syntax we saw earlier. So right now, you might be thinking, oh wow, this is cool. Or you might be thinking, Ashi, you promised compatibility. You cannot go just adding features to the language all willy-nilly. And maybe both. We contain multitudes. The thing is, we're not adding this to GraphQL. And this is backwards compatible. All of this new syntax compiles down to GraphQL. Everything on the left is syntactic sugar for what we had earlier. It's just a little bit cleaner, shorter, and easier to write. This is all possible because we're introducing a compile step, or rather, we're making the existing compile step, which happens in the gateway, more explicit. We're also making it a bit more powerful, and something that you're able to run yourself locally. To be clear, we're not totally set on the syntax, although it does look rather nice to me. Part of why we're sharing this early work is to get some feedback. And the other part of why is to get you excited. I mean, this, I think, is really cool. Can you imagine the process you would have to go through to write a service that does something like this today? Here, with really just a few extensions to federation, we're able to do it without writing any resolvers and without pushing any binaries. These tools let us express joins and delegation and a whole host of data flow concepts within the data layer, where they can be statically analyzed, planned, and validated. That's exciting now, and it's going to be vital in the future. As the space of data that we're working with continues to grow in size and complexity, these are the kinds of tools we're going to need to wrangle, project, and reshape those graphs. You remember the semantic web? This idea that we would create a substrate of machine-readable data on the web with custom CSS classes and spans. And this would make it easy for everyone, from hobbyists to partner organizations, to navigate the massive space of information that we are constantly creating and cataloging. This is the semantic web. This is delivering on that promise. And the work we're doing now is building a language for accessing and manipulating it. We are building new ways to find patterns in the sky. So as I said before, these are forward-looking statements which may contain inaccuracies. Or this is prophecy, which means if you're excited by any of this, you can help shape it. The best way to start is to get into Federation now, so you can be involved in this next phase of development. Apollo's been community-driven from the very beginning. We don't want to do this alone. We really can't do this alone. We can write the tools, but will we write the right tools? We can build a future, but will it be a future for all of us? That's the question in a lot of areas of the world right now, and also here. I'm excited by this work because I'm profoundly a nerd, but also because we're working to make the space of data, a graph of everything, this vast sea of all the information known to all the computers, more intelligible, more accessible. We're creating tools that are easier to hold. We are opening possibilities. We are, hopefully, bringing more people into this world. And I think whatever the challenge is, expanding the space of freedom is a fundamental good. So come along with us on this journey. We're headed to the stars. Thank you. Hey everyone. This is Ashi coming in live, and here to answer your questions. So go ahead and ask them if you haven't yet in the questions for speaker channel. This first question comes from Peggy, who asked, what did I build these 3D visualizations in? There's this library called 3D Force Graph, which uses 3JS and D3's Force Graph layout to do that stuff, given some graph data. And then
I wrote something to traverse GraphQL schemas and collect graph data from that. Next question is from, I apologize if I pronounced this name incorrectly, Riggin. Will Project Constellation support subscription operations? It will. That's the intention. Next question is from Kurt. When I mentioned pre-compilation, can I talk a bit more about how that works? Sure. So currently we do schema composition. We sort of hand the gateway a list of schemas, and it composes them together at runtime on the fly. We just actually introduced a set of directives which let us describe that pre-composed schema. So we didn't have this before. Previously, the schema would get composed in memory into a data structure that just worked within JavaScript. Now we have this intermediate format, and we can generate that from a list of schemas, like do composition from that. And that's the intention, is that you'll be able to take a bunch of schemas and turn them into a single standard GraphQL schema on your computer locally, or also in the cloud, or the gateway will be able to do it as well. It can happen in many places, but the idea is you'll be able to compile it just like you can and run validations and tests locally. Kurt also asks, I love the use of Rust, but what does that mean for other languages? Or is this something abstracted from the developers? So it should be mostly abstracted from developers. In fact, in the initial release, we intended to be kind of a black box that we drop into Apollo server, specifically into Apollo Gateway, and it and the JavaScript structure goes and calls into Rust. Eventually, there might be an opportunity for developers to write extensions to that in Rust, but our intention is that you won't generally have to. That might happen to support use cases that we currently completely don't support. But all of the current code you have to operate gateways and configure them should remain unchanged. We have a question from Twitch. So regarding from, will those queries be executed by the client or the gateway? How does it know what the Gutenberg graph is, and what is the services list config? So the services list config is a reference to the configuration we currently give the gateway, which maps names to schema URLs. And that gives us the set of graphs that are available. We've been having a lot of discussions about maybe other ways to specify that, being able to link in other files, being able to like reference schemas from some repository somewhere. Currently, it's just going to be a file that you provide. Can you go into more? Can I go more into the security and signing of this? I made mention of security implications, and this is from Alex. Alex is curious about where I see that being needed. So one answer is that if you are joining two graphs and their endpoints don't necessarily know that they're being federated, their endpoints might be extracting like tokens from HTTP headers or something. And we kind of need a way to communicate that those headers are necessary. This is sort of a standing thing in federation, where we don't have a standard way to proxy authentication information through the gateway, or even to really know what downstream services need. So we're working on various solutions for that. Currently, it's going to work the same way it works in federation today, which is that you have to know that and have to write some code in your gateway to send whatever auth information is needed to those downstream services. All right, and that is all the time we have. If you have questions I didn't get to, I'll try and jump into the chat to answer them. Otherwise, thanks so much for coming to the talk.